Congratulations, you are tuning in to watch Lesson 3. You are now in your second week of the Probability and Statistical Analysis course. This might be your first online course you've ever attended, so I want to take this opportunity to talk to you about your motivation behind attending this course. I want you to succeed in this course, but realistically speaking, we are only human and some days we lack motivation. According to Shaw Academy's coaching educator, Marianne van Sale, motivation needs to come from a sense of self. How will completing this course impact your life? What change do you want completing this goal to have in your life? Will completing this goal improve your career, finances, personal development, or other places in your life? If we keep doing the same thing, we'll keep getting the same results. Let's get out of our comfort zones. Hello everyone, and a warm welcome back to Shaw Academy. Henry Ford says that if you do what you've always done, you'll get what you've always got. I am Nina Smith, and I am the voice of this course. This is your professional diploma course in Statistical Analysis, Lesson 3, Summarising Data. We will kick off today's lesson with a practical tour around SAS Studio. Since we're going to be using this tool a lot, we need to get comfortable with SAS and make sure we're using it as efficiently and effectively as possible. Thereafter, we will mainly focus on the different methods of summarizing data. Now, in the previous lesson, we were introduced to measures of central tendency, which is one of the ways we can describe the data. Lesson 3 will elaborate on that concept with measures of spread, as well as various ways of visualizing data through plots in SAS Studio. Each topic will be consolidated through a practical demonstration in SAS Studio. With that said, let's kick off today's lesson with our first topic of the day, a SAS Studio tour. In our previous lesson, we drew in the red wine quality data set. We saw a little bit about the different features that SAS Studio has available. Let's explore that a little bit further so that we can truly utilize all the functionality of SAS Studio, seeing as we will be working with this tool for the remainder of this module. Now, we already know that SAS Studio is a developmental web application for SAS that we can access through our web browser. So, if we open a new program, this is how SAS Studio looks when we first opened it. The left-hand side panel is called a navigation pane, and on the right-hand side, we have our working pane. The navigation pane, according to SAS, provides us with access to search functionality, folders, and all the libraries that contain our folders and tables. So, as we have seen, we created the My Folders library under the SAS University Edition folder as a subfolder. And the wine quality dataset is stored in that folder. Then the work area on the right-hand pane, as you've seen, provides a place where the code is showcased. The log tab showcases errors, warnings, and notes. And then the results tab simply outputs the code. So SAS contains a number of built-in data sets that we can use. If we click on the Library tab in the Navigations pane, and we navigate to My Libraries, SAS Help, you'll find a bunch of data sets that are available for us to use. So for instance, let's say we want to use the cars data set. Now, if we expand the cars dataset, you can see these are the variables available in this dataset. And by double-clicking on this dataset, it will open the data set in the right-hand working pane on the right-hand side. Now, this data set has 15 columns and 428 rows available. Another feature that is also available in SAS Studio is currently all the variables are included in this data set. But say we only want to include the make and the model. Then we are able to do that by deselecting all the variables and just selecting make and model. Notice that currently we're looking at the column names, but we are able to change that to say column labels. Then another feature of SAS Studio that's available to us is to add a filter on the make column. So say we want to add a filter and select only Audi and BMW. We'll create a filter for that variable, and then the table will only show cars that are of the make of BMW and Audi. Okay, so say we're happy now with the way that the data looks. Then we can navigate to the query editor, which displays the code that creates the current table. And you can see that SAS has already compiled the code needed to create the table for us. SAS automatically created the code for the specific table that we want. And we're also able to save this code so that we can use it at a later stage again. Okay, so let's look at how we can draw the data into the Results tab through the procedure proc print method as well. The pop-up is your little helper in SAS, but you are able to turn that off if you don't want that by selecting Preferences, and then navigating to Code and Log, and enable autocomplete. So you can switch it off, but I don't want to do that now because I like the trusty SAS helper. So if we just want to print the entire data set, we use the procedure proc print, and we have to specify to SAS where the data set lies. So the data set is in the SAS help table, and it is called cars. After every statement, we need to put a semicolon. When we want to run the statement, we use the statement run followed by a semicolon. Then we click on the little running man at the top. That should give us the results. There we go. We've recreated the data set using the proc print statement. We can also go to the log to see if the data read incorrectly. There were no errors and 428 observations were read in. So we know that that's correct because we know that our original data set contains 420 observations. So we've now printed the results of the proc print statement. The default display of the statement in the Results tab is HTML format. But you are able to change that and view the results in a PDF format or in an RTF file, or you can download it as HTML as is. So let's go back to the Code tab again. And now, instead of printing the entirety of the data set, let's try to print the make BMW and the make Audi, as we did previously. So when we typed this proc print statement, we see that it gives us a whole bunch of different options that we can include with the proc print statement. So we are able to group by variables. So we can group by, for instance, the make of the cars by BMW and Audi. We can also just include certain variables with the car option, like make and model. But then if we really are lost, here at the bottom, you will find a link to SAS product documentation, samples, and SAS notes papers. So there is more helpful information that we can obtain if we click on that link. And it will take us to the support tab for SAS. You can see the link leads us to more information about the proc print statement. It found in the SAS documentation. Okay, navigating back to SAS Studio, let's try to group by make. And let's only include the variables make and the model. So we want variable make and model. Remember the semicolon, and then we run this code. Okay, so we have split the tables by make, but we still need to tell SAS that we only want to see BMW and Audi. So how do we do that? Okay, now we need to only include Audi and BMW groups from the variable make. We use the where option statement for that. The trusty SAS helper tells us that the where statement select observations from a SAS dataset that meets a particular condition. So we will say where the make is equal to, and in inverted commas, Audi, or make is equal to BMW. Let's see if that works. Yes, okay. So now we have a table containing all the Audi observations with the car models and a table containing BMW makes with the different models. And just note that we have to specify the make is equal to one model or another. The same result is not achieved if we do not specify that. In the next demo, we will see how we can use some of SAS Studio's features for summary statistics. There's a few nice click and point functions that SAS Studio has available. And then we will also be creating some graphs towards the end of this lesson. Remember, all the summary notes and slides are available in your toolkit and would really be worthwhile to keep as a resource at your fingertips beyond this course. But no sneak peeks. The lesson notes will only become available after you have attended your class or caught up with the lessons. These will also help you prepare for your first assignment. For the second topic of the day, we traverse descriptive measures like measures of spread in further detail. But first, let's recap what we have learned thus far about describing the data. In Lesson 2, we introduced 3 measures of central location: the mean, median, and mode. These measures all help us to describe the central position of the set of data we're working with. These statistics are known as measures of central tendency or central location. Suppose now we know what the mean is for a particular data set. This is useful information, but having an idea of the spread or variation of the data will provide us with a better understanding of the distribution of the data. A few statistics that are available to us for describing the spread or variation of the data are the range, standard deviation, coefficient of variation, interquartile range, and percentiles. The standard deviation is probably one of the most well-known measures of dispersion. The standard deviation describes the data spread around the mean. It shows us what the average spread of the data points are about the mean. We represent the standard deviation with the symbols SD, where the formula calculates the deviation of each point from the mean and divides that summation by the sample size minus 1. We divide by n minus 1 and not just n, because this provides us with a more precise estimate of the true population. The standard deviation is also the statistic of the square root of the variance. Let's look at an example to better understand how the standard deviation is implemented. If we let x be the score the student achieved in the course, the mean score for a sample of 10 students would be 78,9. Then in the second column, we subtract the mean from each observation. Now this forms the deviations. In the third column, we square the deviation and then sum them, resulting in a summation of 2,338,9. Then we divide this result by n minus 1, and that results in a value of 259,88. This value is also our variance. So in order to get the standard deviation, we square this number and obtain a value of 16,12. The higher the standard deviation, the more spread out the data is from the mean. The range is the difference between the maximum and minimum value of the data set. In other words, the range is the maximum value minus the minimum value. Percentiles. Now this is a term you might already be familiar with. When we talk about percentiles, we mean that it is the percentage of the sample's distribution that is equal to or less than a certain number. For example, if we say that for a specific course, the 90th percentiles for the grades of quiz A is 95%, this means that amongst all the students that took that quiz, 90% scored 95% on the quiz. Our coefficient of variation that we can abbreviate to CV is the statistic we use to indicate the relative measure of spread in the data. The CV is therefore the variation relative to the magnitude of the mean. The CV is calculated by dividing the standard deviation by the mean times 100%. So when do we use the coefficient of variation? We use the CV when we want to compare variables that are measured on different scales. The CV adjusts these scales so that comparison is sensible. That brings us to our last summary statistic we will look into in this lesson, the interquartile range, or IQR. Now, this is the difference between the 25th and the 75th percentiles. In other words, the interquartile range represents the middle 50% of the distribution. We can represent IQR as the third quartile value minus the first quartile's value. So where do we use each of these statistical measures? The standard deviation is used with the mean when the data is symmetric around the mean. This means that the data is normally distributed. 99.7% of the observations will always lie within 3 standard deviations of the mean if the data is normally distributed. But more on this in later lessons. Percentiles and the IQR is mostly used with median when the data is skewed. Skewness and kurtosis are also measures we will discuss in later lessons to come. The range is used to draw attention to extreme values or outliers. And the coefficient of variation is used when we want to differentiate between distributions measured on distinctive scales of measurement. Let's head over to SAS Studio to put the skills gained to practical use. Okay, for the next demo, we might want to find out more about summary statistics of the CARS dataset that we have started looking at in the previous demo. We can do that by navigating once again to Tasks and Utilities. And then we go to Tasks, and then we navigate to Statistics and Summary Statistics. Okay, so here we can select our data set cars, and we can also then say which variable we want to investigate further. So that is which variable we want to describe in terms of summary statistics. So say we want to look at the weight of the cars in a bit more detail. SAS automatically generates the code for us. Here on the right-hand side, you can see SAS used the proc mean statement. We should be familiar with this statement because we've used it in lesson 2. So we should know that the proc mean statement gives us some summary statistics. And then we run the code. And then in the results pane, we can see that the means or the average weight of the cars is 3,570, almost 78 kilograms. We are showed the standard deviation, the minimum, the maximum, and the amount of observations. Let's say we want to investigate the variance further. Okay, so we can include that by navigating to options, and we select all of the summary statistics we want to include. Let's include the variance, the range, the first quartile or the first percentile. That is Q1 and Q3, which is, of course, our 75th percentile. That is the upper quartile. Let's click on the running man icon. Okay, so you can see we now have the minimum, maximum, and the range, which is the maximum minus the minimum, and the standard deviation and the variance. Remember, standard deviation is just the variance squared. Now looking at the median, that's the middle value that divides the observations into the halves. So 50% of the data falls below this number, and 50% of the data falls above the median value. Then Q1 is the 25th percentile, and the upper quartile should be there, the 75th percentile. And when we navigate back to the Code tab, we can see that everything was obtained with the proc means procedure. And all that SAS did was it added options to the statement. So it added the mean, standard deviation, minimum, maximum, and all of these values that we requested. It included these in the results. But say you want to change the code or maybe change the order a bit. So maybe you want to see the results in the order of minimum, maximum, and then the range. So we click on Edit to change the order and remove some variables. Okay, so let's run this code in order to view the result. There you go. So you can see that it's quite easy to rearrange the order or to remove some variables from the statement by manually changing the code. Will the next lesson be as great as this one? Even better. In the next lesson, we will delve deeper into the concepts of probability. We will seek to understand the principles of samples and populations better and deal with some methods of sampling. Congratulations, you made it to the last topic of the day. Let's have a look at how graphical representations can influence the way that we investigate data and the significance of each. Well, let's be frank. Looking at a bunch of rows and columns is boring. It's neither interesting nor informative. Visualizing data helps to sketch a better picture of the data. Plotting data also helps to highlight trends in the data. That way, it is easier for us to understand the jumble of information, and we're better able to tell a story through the data. Visualizing data also helps to spot outliers. and highlight the distribution of the data. The stem and leaf plot is used for tallying observations. Our stem and leaf plot picture shows most observations lies in the 40s range. Observations can of course be grouped in any other sensible manner, like groups of 5s instead of groupings by 10s. Stem and leaf plots is a concept we should all be familiar with from secondary education. The histogram is also called frequency histogram, graphically representing frequency distribution. Histograms can be useful for large data sets involving quantitative variables. Remember, histograms contain no gaps, unlike the box plot that has gaps because data are continuous. An example of a histogram is the scores of students from quiz 1 of this module. A box plot is also known as a box and whiskers plot. Can you see the diagram's whiskers in green? We use a box and whiskers plot to display information about the Q1, Q2, and Q3 value locations in the distribution. The box plot is used to convey information about the minimum value, the first quartile or Q1, the second quartile or median, the third quartile or Q3, and the maximum value. Box plots can help us to spot extreme values more easily. The last graphical representation we will touch on for today, but certainly not the last one available to utilize, is the frequency polygon. The frequency polygon is a line graph that is alike to the histogram. Before we pop over to practice all the knowledge we have accumulated, let's look at some of the pitfalls we need to avoid when using visualizations when representing data graphically. It is always good practice to represent data on a single scale in order to avoid confusion. In the case of a bar chart or histogram, a baseline should be included in order not to misrepresent the data. Start with the basics. Is your data clean? Never cherry-pick the data to show what you wanted to show. Visualizing data should be an objective representation of the data. Remember to use the correct visualization to represent the data type. And lastly, never manipulate the X or Y axis in order to make the data appear differently distributed. Let's pop over to SAS Studio for the final time today to put into practice all the skills we have accumulated. For the last demo of the day, I just want to show you a little bit about the rest of the functionality that's also available in the SAS Studio in the Tasks pane. Okay, navigating to the Graph tab, we find we can also insert a bar chart. Let's double-click on that function. For the category variable, let's select the make of the car. And then for the subcategory variable, let's select the weight variable. And then we have to say, how do we want to display this information? Do we want the bars clustered side by side or stacked on top of one another? Let's select clustered side by side, the default option. We can also include a title by navigating to the Appearance tab. Let's run the code to see how the outcome will look. Okay, so this is now the graph that we've created. As you can see, this graph is not a good representation of the frequency of each car by weight. There is just too much information in this plot to even read what make each car is. So you can see that it's quite easy to create a graph. But it doesn't help that you just create a graph and you aren't able to extract useful information from it. The graph has to make logical sense. So let's clean up this graph a little bit so that we are actually able to extract some useful information from it. Okay, first of all, let's remove the subcategory and just look at the amount of cars per make. And let's run that. You can see this graph is still quite cluttered and it's still quite difficult to even read what these labels are saying. Now I've created a filter for the make of the car. All I did was click on the filter icon And in the same way that we filtered the Audi and BMW make in the coding console, I told SAS Studio that if the make is equal to Audi, or if the make is equal to BMW, include those options in the graph and display that. So the bar chart is only showing the count of the make of the cars if they are Audi or BMW. Now, this is one way to better see what's going on in the data to investigate makes of the cars of interest a few at a time. We could also split the makes of cars into groups depending on similarities between groups, or we could only investigate the most commonly occurring frequencies. These are just some examples of how you would be able to utilize this information on the plot better and have the visualization aid to make better decisions based on your data. Our mission here is to change lives by providing great education, which is accessible and affordable to everyone all over the world, giving you the flexibility to learn your way. Do you feel like we're living up to this mission? Are you finding the course to be flexible and engaging? Are you learning your own way? Have you managed to wrap your mind around some practical skills yet? We are here to facilitate real success according to your goals. It's time to stop and reflect on the progress you've made thus far in this journey. In just a mere 3 lessons, we have made amazing progress. We now have a better understanding of organizing, summarizing, describing, and displaying data. Imagine how much more you will learn if you keep on showing up for more lessons. In each lesson, I will propose a bit of a challenge to you as the student. This challenge may have some concepts you will have to read up on because the goal is to challenge you. For this lesson challenge, I want you to visually represent the continuous numeric variable from the red wine dataset as a histogram with a frequency polygon superimposed on the plot. And before you could even blink, you have reached the end of lesson 3. I cannot wait for us to continue this journey in lesson 4.